This lesson is on the definition of the derivative, and we'll show how it's connected to the notion of the slope of a tangent, and we'll be using limits to do that. So the function I want to work with is x squared plus 3x minus 6. We want to find the slope of the tangent line. To the function at the point where x equals 1. That's our goal. So let's visualize that. Let's see that. So I will pull up Desmos. And x equals 1 is here. So the x value is 1, the y value is -2. So before we do this, can you eyeball it? Can you say, okay, look at what the tangent line would be, kind of draw a mental drawing of that tangent. Is that slope positive or negative? Can you guess approximately what it'll be? So that's what we're going to look at. We're going to look at that function at that point. We're going to try to find the slope of the tangent line. So how do we do that? What's our idea? Let me exaggerate that a little bit. So here is our function, let's say at 1. So this is the point where x is 1 and the y value is f evaluated at 1. So we're going to deviate just a little bit from this. I guess this is the x-axis, even though it's negative, but you get the idea. So this is 1, and I'm going to move away from 1 a little bit. I'm going to change up x. I'm going to call it 1 plus h. I'm going to find out where is that on the graph. That's here. So this point, x value is 1 plus h, and the y value is f of 1 plus h. And we're going to draw a secant through these 2 points. It's supposed to be a straight line. We draw a secant between those 2 points. Now, what is the slope of that secant? Slope is change in y over change in x. Change in y, f of 1 plus h minus f of 1. Change in x, 1 plus h minus 1. So we get our slope will be what? Will be f of 1 plus h minus f of 1 over h. Slope of what, though? What did we call this? This green thing was a secant. So the slope of the secant is going to be that. So let's try to draw a slightly better picture. So again, exaggerating. Here's 1, f of 1. Here's 1 plus h, f of 1 plus h. Secant line is here. So what has to happen for the secant to become the tangent? Well, h has to get closer and closer and closer and closer and closer to 0. If h gets smaller and smaller, the secant becomes a better predictor of the tangent. So let's see, here's another secant line here, right? That's better somehow than the first example. So the slope of the secant, again, is change in y over change in x. Change in y, f of 1 plus h over f of 1. Excuse me, minus f of 1. Over change in x, which is 1 plus h minus 1. So we get f of 1 plus h minus f of 1 over h. That is the slope of our secant. But how does it become the tangent? When does the secant turn into the tangent? Secant mean cutting through the graph. Tangent mean just kissing into the one point. So don't confuse these with the trigonometric notions of secant and tangent, different concepts here. the slope of the tangent would be the limit as h goes to 0. So h gets smaller and smaller and smaller. The secants get better and better and better and better. So the limit as h goes to 0 of what? Of f of 1 plus h minus f of 1 over h. That is the slope of the tangent line. That is what we're going to try to find. So our example here is x squared plus 3x minus 6. So let's go ahead and use that. So we have f of x is x squared plus 3x minus 6. We said over to the side that the slope of the tangent is the limit as h goes to 0. Is the limit as h goes to 0 of f of x plus f of 1 plus h minus f of 1 over h. So what am I going to do? Well, we're going to go ahead and find f of 1 plus h. What is f of 1 plus h? Plugging in 1 plus h for x. 1 plus h squared plus 3 times 1 plus h minus 6. Simplifying. 1 plus h times 1 plus h. What is that? Right? 1 plus h times 1 plus h. 1 plus h plus h plus h squared. It's 1 plus 2h plus h squared. Three times 1 plus h plus 3h minus 6. So let's simplify this if we can. What is f of 1 plus h? Like terms, they only have 1h squared, which is here. H's, 2h, and 3h would be 5h. And then the numbers, what are my numbers? 1 plus 3 is 4, minus 6 is negative 2. So that's f of 1 plus h. Again, keep your eyes on our prize over here. Limit as h goes to 0, f of 1 plus h minus f of 1 over h. How about f of 1? Would be plugging 1 in for x, 1 squared plus 3 times 1 minus 6. 1 plus 3 minus 6, 4 minus 6 equals negative 2. So now I want to take a look at f of 1 plus h minus f of 1. What is f of 1 plus h? Minus f of 1. F of 1 plus h is h squared plus 5h minus 2 minus f of 1 minus negative 2, all divided by h. Again, we're going to take the limit as h goes to 0 of that eventually to get the slope of our tangent line. Well, minus 2 minus negative 2, those go away. And I get f of 1 plus h minus f of 1 over h equals h squared plus 5h over h. And the h's can divide out. Let's factor out the h. H times h plus 5 over h. The h's divide out, and the result is h plus 5. But again, keep your eyes on the goal. The slope of the tangent is the limit as h goes to 0 of that. So keeping that in mind now, the slope of the tangent, where this was at x equals 1, equals the limit as h goes to 0 of f of 1 plus h minus f of 1 over h, which is the limit as h goes to 0. What did we do? We said all of that was h plus 5. Well, just plugging in 0, I get 0 plus 5, and I get the slope is 5. Now that's supposed to be the slope of our tangent. So let's go back and take a look at our graph. Again, based on our computation, we believe the slope of the tangent here is 5. So what am I going to do? I have the point. The point is 1, negative 2. And I need a slope to be 5. So the point, again, is 1, -2. And the slope is 5. So we want to find the equation of the tangent line to check to see what it looks like. So again, using our point slope form, y minus y1 equals m times x minus x1. Y minus -2 equals m 5 times x minus x1 times x minus 1. So we get y plus 2 equals 5x minus 5. Subtracting 2 from both sides to put it in more of a function form or slope-intercept form, y equals 5x minus 7. So let's see if this is truly the equation of the tangent line that goes through that point 1, -2. So we're going to graph it y equals 5x minus 7. And there it is. There's the idea. So if I zoom that thing in, the red tangent line and the purple parabola should be basically the same thing there. Are they? Basically the same thing? Yeah, I think so. I think so. So now what does this mean? What did we do? Remember, our original question was this. Was to find the slope of the tangent line. We then used that slope to find the equation. But the slope of that tangent at x equals 1 was 5. So what is our notation? What do we say to that? The notation we use is f prime. That represents the slope of the tangent at the value 1 equals that slope of the tangent there was 5. So that's the notation we use. F prime is called the derivative of f, first derivative of f. And f prime of 1 is defined as, again, using this whole concept, f prime of 1 is defined as the limit as h goes to 0 of f of 1 plus h minus f of 1 over h. Now we could also do this to find the slope of the tangent at 2, at 3, at -1, at -17. We could do all of those, or we could find the derivative function. So let's talk about what that means. What do I mean by the derivative function? So I have a function here. Again, I'm going to exaggerate it, looking like this. This is a point x, f of x. I'm going to deviate just a little bit. I'm going to add a little bit to x. So this point over here, x is moved over by h. This is the point x plus h, and then the y value would, of course, be f of x plus h. And I want that limit to shrink to 0. So the secant first, remember, the secant intersecting the curve, not necessarily while approximating it. This is the secant, right? So the slope of the secant, I'll use m for slope. Slope of the secant is change in y over change in x, which would be what? Which would be f of x plus h minus f of x over x plus h minus x, which gives us f of x plus h minus f of x all over h. But to get it to be a tangent, what's the slope of the tangent? It's going to move even closer. Maybe x plus h is here, or x plus h is there, or x plus h is there, or x plus h is there. As it gets closer, the secant becomes a better approximator. So the slope of the tangent is the limit as h goes to 0 of the slope of the secant, which is the limit as h goes to 0 of f of x plus h minus f of x over h. That's our idea. And that is called the derivative function. At every point x, that gives you the slope of the tangent at that point x. So f prime of x is the derivative function, is defined as the limit as h goes to 0 of f of x plus h minus f of x over h. This will give us the slope of the tangent at every point x. We did it for 1 in our first example. This will give it to us for any point x that we choose to use. All right. So let's do that. Let's do it for our function, which again was x squared plus 3x plus 6. F of x is x squared plus 3x plus 6. We want to find f prime of x, the derivative function, which will be what? Which will be the limit as h goes to 0 of f of x plus h minus f of x over h. Okay, so let us do this. So what is f of x plus h? Is x plus h squared plus 3 times x plus h plus 6. Let's make sure we're clear on what x plus h squared is. X plus h squared is x plus h times x plus h. X squared plus xh plus hx plus h squared, which gives me x squared plus 2hx plus h squared. So that's our x plus h squared. So we'll put that in first. X squared plus 2hx plus h squared plus multiplying 3x plus 3h plus 6. And there's no like terms here. So let's just write it one more time. F of x plus h equals x squared plus 2hx plus h squared plus 3x plus 3h plus 6. Underneath it, I'm going to write f of x. Remember, we need f of x plus h minus f of x. Watch how I'm going to do this. F of x is x squared plus 3x plus 6, but I'm going to put the x squared here, the 3x here, and the 6 there, so that when I subtract, what happens? F of x plus h minus f of x. What happens? X squared subtracts out x squared minus x squared, that's gone. Then I have 2hx plus h squared. 3x subtracts out 3x plus 3h. 6 subtracts out 6. But you can see I need f of x plus h minus f of x over h. So let's do that next. F of x plus h minus f of x over h is 2hx plus h squared plus 3h over h, which you'll notice I can factor an h out upstairs. H times 2x plus h plus 3 all over h, and the h's divide out. And we're almost there. So to finish this off, f prime of x is the limit of all that. So remember, that's the slope of the tangent. Remember, right? The slope of the tangent at every point x is called f prime of x, which is the limit as h goes to 0 of f of x plus h minus f of x over h, which we've just done, and the result is 2x plus h plus 3. Now be careful, you're plugging in the h of 0, not the x of 0, which gives me 2x plus 0 plus 3. So the conclusion then is f prime of x is 2x plus 3. So if I want the slope of the tangent at any point, I can go ahead and just use this formula. So there is certainly an advantage to doing it this way. So let's go back to our graph. And let's say we are interested in this point, -3, -6. And I want to create the tangent at that point. So I want to find the slope of the tangent there. Well, the slope of the tangent is f prime of -3. So the slope will be f prime of -3. So let's make sure we understand the question. Our function f of x equals x squared plus 3x plus 6. Our derivative that we just did, f prime of x, is 2x plus 3. We want to find the slope of the tangent and then eventually the equation of the tangent. Find the slope of the tangent line. At what? At x equals -3. So, and then eventually we'll use that to find the equation of the tangent line. So the slope of the tangent is simply f prime of -3. Plugging that into f prime of x, 2 times x plus 3, 2 times -3 plus 3, which is -6 plus 3, which is also -3. So the slope is -3. The point, remember the x value was -3. What was the y value? The y value here is -6. So we're going to again use point slope form to find the equation of that tangent line. Y minus y1 equals m times x minus x1. Y minus -6 equals m, which is what? Which is -3 times x minus -3. A lot of minuses here. So y plus 6 equals -3 times x plus 3. And I'll leave it in this form, and we'll see if indeed that is the tangent line at that point. Going back to Desmos, we will turn off the other tangent line, and we're at this point, -3, -6, and I'm going to try to graph y plus 6 equals -3 times x plus 3. And how does that green line look? If I zoom in on that, do you see that that's a good approximation for the function? The function in green seems to match the function in blue. You zoom in close enough, they are basically indistinguishable.